Hello Internet. You guys want to know what happens when you end up using a wrong screw on a STRIX 3090 that gets inserted into these two holes? And what's funny about this is that a lot of times these screws are too long from the factory, almost as if Asus designed this to fail in this way. And all it takes, literally, is a little bit of pressure as you screwing these things in. And then what happens is this. The screw had drilled into a couple of layers of the board, shorted several lines, as well as on this end. It's a lot less significant, but nonetheless, traces are damaged. And as a result of that, we have a short on 12 volt, and that short is originating at this driver MOSFET here. As you can see, it's slightly bulged and burned, and that's all thanks to a screw that was pushed in a little bit too hard. What could potentially happen when any of these traces get caught or damaged or shorted? God knows. But I think what could potentially happen is that if these traces are feedback or PWM signals, if they short one another or they fail to supply feedback to the NVVDD controller, the driver MOSFET becomes overloaded, potentially supplying too many volts into the core, and it being overloaded with so much voltage probably shorts internally and causing all sorts of problems. And given the fact that the Asus neglected to put 12 volt protection on the board by implementing fuses, the consequences of that could be catastrophic. So today we're going to find out whether or not this board has survived. So first order of business, I'm going to replace this driver MOSFET, and then I'm going to start fixing these traces, and I'm hoping for two things. Number one, I'm hoping that the driver MOSFET is actually removable from the board so that I wouldn't have to grind it out of the board. And also I'm hoping that this driver MOSFET did not fail in such a way that it would supply too many volts into the core, potentially killing the core. There's absolutely no way of knowing this until all of the repairs are done. So that's why these repairs are so interesting, is that you're always in the unknown until everything is fixed. So let's get that fixed and see if that helps. That's it. Driver MOSFET replaced. Traces are fixed. I will deal with the screws later. Let's see if we still have a short on 12, which I did not show you earlier. But believe me, it was there. So we are still short, as you can see here. So the short was not fixed by replacing that one driver MOSFET, which means, given the fact that several more traces were cut, most likely more driver MOSFETs are failed. So let's continue on looking for trouble. Memory looks good. This is, I believe, 1.8 hex. This is 12 and 5 volt is here. So we're good. Good. So the only thing that we still have is the short on 12 on these two coils, or just this one. Okay. Yeah. So before it was short on this connector and this. Now it's only on this. So let's go and figure it out. Which of the driver MOSFETs is still shorted? Can you see it? A very, very faint heat signature. So we're going to look for more just to make sure. And this little guy, if we can find it again, Yeah, this one. Pulls about 3 amps, so that's why it's a little bit difficult to detect. So if I wanted to see it a bit more obvious, I could increase the voltage, but that always comes with a risk of having that voltage leak past the driver MOSFET into the core, so we're not going to do that. So let's go ahead and replace one more driver MOSFET, and hopefully that's it. Hopefully you can see here at the bottom that we could have noticed this driver MOSFET without the thermal camera. It has a sign of a blowout on its side, as you can see, by this solder ball that does not seem to belong anywhere. That goes to show that the visual inspection can be way more effective than expensive and fancy thermal imaging camera. There. Look how clean this is. And it's all possible thanks to Black Horse Repair Flux, the easiest to clean flux I've tried so far. Black Horse Repair Flux. The flux that rocks.
Thanks, Tony.
Thanks, Steve.
And the short is gone.
I am done. Short is done. Customer is gone, probably. What more do you want?
All thanks to the magic flux.
The best flux.
Alright, I think Black Horse had enough of free advertisements for the day. Let's see if this thing will power on. And we're going to arm ourselves with a thermal camera so that we can spot any issues before they go catastrophic. So let's see what happens when we flip the switch.
Power supply is on. Nothing smoked.
Woo! See? I told you. Thermal camera is going to show it to me way faster than anything else. So, thermal camera is noticeably important all of a sudden. Let's pinpoint the faulty driver MOSFETs. It's gonna be this one here. Okay, so we're gonna mark that. And we also had one on this end. It's gonna be this one here. And it just so happens, if I'm not mistaken, it's right next to the one that we've replaced previously, as well as possibly this one too. So it seems like their neighbors went off as well. Let's go and replace the 2 more driver MOSFETs, and hopefully it will power next time. Now here's what's interesting. The driver MOSFET that we replaced previously was this guy. Now this guy is acting as if it's failed. But on this end, the failed driver MOSFET is actually the one that we replaced. So it's not even its neighbor. It's actually the very same one. Why is that? I do not know. Possibly the problem isn't this driver MOSFET, but the other one? I don't know. Or maybe its neighbor is also haywire, and all we're doing is wasting our time replacing it, given the fact that their PWM signals could be linked. So we could go into the board view and see which one could cause the problem, or we can simply remove it while the board is still hot, power it on, and see if its neighbor is acting up. And if it does, then we could potentially think or conclude that this one is actually good, whereas its neighbor is actually bad, causing the good one to act as if it's bad. Hopefully that makes sense, but let's do one thing at a time, see what we can discover. Now the issue I'm having is, what if the driver MOSFET is fine, and the driver MOSFET that's on this end is also fine, and that the problem is actually at the PWM generator, or the buck converter, or the phase controller, acting up, causing these driver MOSFETs to behave radically. So instead of filming me replacing this, that, and potentially the controller itself, I'm going to go and do all of that myself, and then show you the end result and tell you which of the components have failed. Otherwise it's gonna be a long day. It's gonna be a long day for me regardless, but for you it'll be more entertaining that way. Okay, so I do not see the short on this end anymore, but I think it had more to do with the controller than with the driver MOSFET, because nothing changed when I replaced the driver MOSFETs. But when I replaced the controller, I accidentally rotated it 90 degrees in the wrong direction.
Stupid.
And so everything still works, but this one driver MOSFET still gives me trouble. And the reason for the trouble is because the PWM pin that goes to that driver MOSFET is shorted, whereas none of the other pins are. So none of the other pins are shorted except this one. So I don't know if it's the driver MOSFET that's bad or the controller.
Lewis would have fired that person like yesterday.
So what we can do is to remove the resistor, this resistor here, and effectively disconnecting the controller from the driver MOSFET, and that's how we will know 100% which of the two is bad. So let's do that real quick. Let's just move this resistor out of the way like so and see if we're still reading short, and we do. So the short is on the driver MOSFET side. So let's go ahead and put this back on here like so, and let's go and replace, I believe it was one of the first driver MOSFETs that we replaced. So 1, 2, 3. Yep, this is the driver MOSFETs that's shorting out this pin for whatever reason. So faulty driver MOSFET from the very beginning, and this one had nothing to do with it. It was just an echo of this one going bad. So let's replace this thing with the other driver MOSFET that was marked as bad before, and hopefully this time we'll get a fix. Alright, let's see what we got now. That looks good. These two that are hotter than the rest are memory, perfectly normal. Okay, so we're missing like several phases. These are all turned off, so let me see if I can show it to you on the thermal camera. So you can see like all of the NVVDD phases are somewhat cold, and only some of them are actually working, like this one and this one. And then we have most of the MSVDD functioning, I believe. That's perfectly normal for this card. This card is rather weird. It has this kind of power saving thing, or whatever this thing is. I call it a headache. It prevents you from seeing all of the power stages activated unless you power this thing on by the PC. I'm not exactly sure why it does that or how to go about bypassing that. I don't know how, and I don't really care. So I will be able to see whether or not all of the power stages are fixed by simply pressing the power button and not plugging in the HDMI cable, not yet, so that we can have a look. So let's turn it on. You can see here they're all glowing on this end, and all of them are glowing on this end as well. So let's go and turn this thing off, plug in the HDMI cable, and let's hope for a picture. Hopefully we won't have to reball the core on top of everything else. That would be epic. And there we go. The card posted.
We did an amazing job on the soldering, so
I have no reason to suspect any issues, but time will tell. I'll go ahead and put this whole thing together, run some tests, hopefully everything's okay. And that's it. Now, where did it all started? It started with a customer thinking he's got the cojones to replace thermal pads. And once thermal pads were replaced, which oddly enough were actually correct, he ended up driving that screw a little bit too far, creating a short, subsequently killing 3 driver MOSFETs, a phase controller. Luckily, the core survived. So here we are, and learning a lesson which is rather simple.
Consequences.
Maybe it's worth sending your GPU to a trained professional for something as simple as replacing pads, or maybe not. It's up to you. Goodbye.